Solving problems of physics are the only way to understand how laws of physics work. There is no other way to understand physics. So here I have a very beautiful problem from SBT. This book is very good for those who are preparing for IIT-JEE Advanced Physics. This question involves a concept of collision. You can say variable mass dynamics also. But I'll use another concept borrowed from sound, Doppler effect, to make the solution easy. To enjoy this beautiful problem, I would like you to give it a try first. I'm reading the question, give it a try. And if you not get the answer, see the solution. So here is the wordings of the question. The question states, a car of mass m is free to move on a frictionless horizontal surface. A gun fires bullets on the car. The bullet leaves a stationary gun. This is a stationary gun with a speed u and mass rate is b kg per second. Mass rate is b kg per second, mean the mass coming from here dm by dt. I can write dm by dt is b. The bullets hits the vertical rear surface perpendicularly while traveling horizontally. All collisions are elastic. If the car starts at rest, initially the car is at rest, find its speed as a function of time. So now let's go ahead and understand this problem. So first of all, I will use a concept of Doppler effect. In Doppler effect, suppose this is a source. My font size is very small, so I will enlarge this part of the video. So suppose the source is moving with some velocity vs and there is an observer who is moving with some velocity say vu. The motion of source and observer are along the same line. And I choose a symbol for the velocity of sound with respect to ground as a c. If the sound emitted from source has a frequency f, then the sound received by the observer or the sound heard by the observer has suppose frequency f dash. Then the value of f dash according to Doppler effect is given by relative velocity between sound and observer, that is in this case the situation that I am showing here is c plus v naught divided by relative velocity between sound and source, in this case that is c minus vs, into a frequency of the sound emitted by source. The meaning of the frequency of the sound emitted by source is if the frequency is f, so you can say that in 1 second f complete waves are emitting and the observer is receiving in 1 second f dash wave. So here what we can relate with, in every 1 second the masses emitted from, actually the bullets are emitting and I am connected to the mass. The mass emitting from the gun is b, dm by dt. Because after collision this cart will start also moving. Suppose at time t the cart has got some velocity v, and if I station an observer at here at the cart, the masses striking at this cart in every 1 second will not be b. It's same as the frequency emitted by the source here is f, the frequency received by observer is some f dash. So same way, if the mass emitted by the gun per second is say b, then the mass striking to the car will be different because now there has been a relative velocity between this cart and the gun. So using this analogy, if I say that say dm dash by dt is the rate at which the mass is striking the cart. So dm dash by dt, you can say that in dt time dm dash mass is striking the cart. Again I am repeating, in dt time dm dash mass is striking the cart. So using the Doppler effect formula, I can use now here on this balls, the relative velocity in place of sound I have a bullet which is moving with velocity u. So relative velocity between sound or the bullet with the observer which is moving with velocity v. So that is how much, u minus v divided by relative velocity between sound and source, here relative velocity between bullet and gun. So that would be how much, u minus 0. Here the frequency of the sound, here the rate at which mass is emitted by the gun. So that you can write dm by dt. So now I've got the rate at which mass is struck to the cart. So in dt time, if dm dash mass is being struck at the cart, so again I'm writing dm by dt, I will write b. So this is simply u minus v by u into b. And now coming to here, all collisions are elastic. So according to this observer, this bullet is going to strike this surface or the rear surface of the cart. So velocity of approach is u minus v, and elastic collision, so velocity of approach is equal to velocity of separation. So velocity of separation is also u minus v. So this observer, according to this observer, with respect to cart, the bullets are coming with respect to this. So with respect to, I can say, cart, the bullets are coming with velocity u minus v. And with respect to cart, bullets are leaving with velocity u minus v. So in dt time, dm dash mass is striking. So the change in momentum of dm dash mass would be how much in dt time? Dm dash into change in velocity with respect to this. With respect to this, the change in velocity is twice of u minus v. So with respect to this, the force that is being struck on this, with which the balls are striking, the force on the cart would be F. That F would be how much? The force is the rate of change of momentum. So in dt time, dm dash mass is striking, and the velocity of that dm dash mass is changed by the amount u minus v minus of u minus v, that is twice of u minus v. So force acting on this cart will be twice of u minus v into dm dash by dt, and we can put the value of dm dash by dt from here. So putting the value of dm dash by dt, you will get twice of u minus v whole square by u into b. So far so good. Now we've got the force acting on this cart at time t, and this force is F. So I want to now write the differential equation of the motion for this cart. So I will write m into dv by dt is equal to F external, and that F external this. So m dv by dt is equal to m dv by dt I have just written here, and this F is equal to how much? Twice of u minus v whole square b by u. Let's rearrange the things. So dv divided by that u minus v whole square is equal to twice b upon mu dt. Now integrate it with suitable limits. At the initial moment, the car was at rest, so v is 0. And at time t, suppose cart has achieved velocity v, and that's what we have to find. So now it's only a matter of solving this integration. So integrating this integration, you are going to get 1 upon u minus v, and lower limit, upper limit, and this integration is 2 bt divided by mu. Put the upper limit and lower limit, so you will get 1 upon u minus v on putting upper limit, and minus 1 by u, or lower limit. So 2 bt upon mu. More simplifications, 1 upon u minus v is equal to 1 by u plus 2 bt divided by mu. So I can take mu as a LCM. So here that will be m plus 2 bt. So now u minus v would be how much? Mu divided by m plus 2 bt. So v would be how much? U minus mu upon m plus 2 bt. So here, so now v would be how much? Little bit more calculation. Now we have come to the final stage. So take m plus 2 bt LCM. So that would be how much? Mu plus u into 2 bt minus mu gets cancelled. And if I divide this numerator denominator by 2 bt, so finally I will get this is equal to u divided by m by 2 bt plus 1, and that is our final expression. So what does this final expression tells? The final expression tells that as t tend to infinity, after a long time, this v will tend to, this t tend to infinity mean m upon 2 bt will tend to 0. So this v will tend to u. So it means with every collision, the speed of this cart keep on increasing. It cannot become more than u, because once it becomes u, so the ball will not be able to ball, or the bullet will not be able to reach this, because already some distance has been traveled and the gun is stationary, the velocity of the bullet is fixed, and by repeatedly collisions, cart has achieved a velocity u, and no further collision can occur. So the maximum velocity the cart can achieve is u. So that is our final expression